Hi, I'm David with Portrait Displays, and in this video, we're going to walk through calibrating the Boland 4K 27 HDR OLED using Calman Studio, the C6 colorimeter, and the G1 pattern source. Let's get started. I'm going to come over to my computer running Calman and double-click on Calman for Business. Now, the Boland monitors include in both Calman Studio and Calman Ultimate. For the purpose of this video, we're using Calman Studio. With Calman launched, I'm now going to come over to the top left, click on Calman, come down to Open Workflow Template, select Display Specific, and choose AutoCal Boland. This is going to load the custom workflow we developed in conjunction with Boland for the Calman Ready Boland monitor. On the welcome screen, I'm able to choose the type of calibration I'd like to do. I can select SDR or HDR. I'm going to select SDR to start the calibration with my standard dynamic range content. After I select SDR, I'm going to come down to the bottom right and press Next. Now I'm on the hardware setup page of the workflow. I have three things I want to make sure are connected to Calman. I have my C6 colorimeter, which is going to be connected to my Calman machine over USB. I've got a G1 pattern source that I currently have connected over an Ethernet cable, but it also works over Wi-Fi. And then I have a network cable connected to the back of the Boland monitor, connecting that to my router. Calman's going to connect to the monitor over the network, it's going to connect to the G1 pattern source over the network, and it's going to connect to the C6 over USB. We'll also have an HDMI cable currently running into the HDMI input on the Boland monitor. Let's get started connecting our equipment. I come over here to Hardware Setup, I'm going to press Find Meter. I can leave all meters except those listed below selected and press Search. Now that the C6 colorimeter is connected, you'll notice there are some meter profiles here below. If I click on this, you can see all the C6 meter profiles supported in Calman. If you come down to where you see Boland X4K 27 HDR5 OLED, you'll notice we actually have a meter profile built in our calibration lab specifically for this model. For more information on meter profiles and why they matter, please click on the link down in the description to watch our meter profiling video. Let's come back to Calman and press Find Source. Calman now brings up the Find Source window. In this window, you can choose any manufacturer and model supported by your version of Calman. Today, we're going to choose Portrait Displays as the manufacturer and G1 as the model. You'll notice the Portrait G1 has been auto-discovered on the network. I simply have to select the Portrait G1 and press Connect. On the right side of the screen, you'll notice we recommend a setting for AutoCal at a 10% window with a 2-second delay. We also want to ensure the generator is correctly set to SDR or HDR. Since I'm doing SDR first, we're going to press Open Settings Panel. Now that the settings panel has been opened, we can go through the generator settings to configure it for the calibration. The window size, we're going to leave it 10%. We'll leave our delay at 2 seconds, our color format in RGB 8-bit, our output, I can change that to 3840 by 2160 at 24. Now it's important to note that whether I'm setting 1080p, 1080p 60, 2160p at 24, it shouldn't really matter with the calibration. These are just refresh rates. Sometimes you might notice subtle differences with some display technologies, but for the most part, a great display isn't going to have a difference just because you're changing the frame rate and the resolution. We'll leave this at 3840 by 2160 at 24 frames per second, and we're going to want to set the range to full range for the calibration of the Boland monitor. Our HDR is currently set to off, which is exactly where we want it for the SDR calibration. Let's click off the settings panel, and let's come down to Connect to Display. We're going to press Find Display, and the Find Display prompt comes up on the screen. You'll notice that the manufacturer is already set to Boland and the model is set to Monitor. We're going to want to type in our IP address, but there's a couple things we should go over with the Boland before we get connected. Step 1, you want to make sure you're running the correct firmware. Calman integration has been done with the latest firmware from Boland. So I'm going to press the menu button, press the up arrow until I come over to Info, and press Select. You'll notice my firmware version is 07.030.004.024. with version 21 on the FPGA. You're going to want to have at least this version on your Boland monitor to use Calman's calibration features. With the right firmware on your monitor, the next thing I'm going to want to do is I'm just going to want to reset my monitor. I'm going to press Menu, arrow over to Setup, press Select, Setup Load, and load the factory menu. The reason we're going to want to set the display back to factory before performing the calibration is that Calman touches most of the display's controls in terms of the calibration of the video signal, but it may not touch all the controls that you set up in your daily workflow of the Boland monitor. While most of these aren't going to affect the calibration itself, it's often recommended to get everything to a baseline before setting up your customizations and working through your workflow process. Now that the monitor's been reset to factory, let's get it back set up for the calibration. I'm going to put it back on the HDMI input by pressing HDMI. That'll bring us back to our G1 pattern source. With the display reset to the factory state, I can now come back and see where my IP address is. Let me press Menu and arrow over to Setup. Press Select and come down to IP Config. This is where you're going to be able to get your IP address to enter into Calman. My IP address is 10.23.11.11. So let's come back to Calman and let's enter that address, 10.23.11.11, and press Connect. Okay, so we've now made sure our Boland monitor is on the latest firmware, we've loaded the factory defaults, and we've got our IP address to connect it to Calman. But you'll notice we're still missing one thing. We've got our C6 colorimeter sitting here on the table and not set up to make calibration measurements. That's going to be a little bit of a problem. So I'm going to come back to Calman, click on the Portrait Displays G1 in the top corner, come down to Specialty Patterns, and load the alignment pattern. Okay, with the alignment pattern on screen, we're now going to take our C6, I'm going to remove the diffuser, we're going to take the counterweight, and we're going to position this over the display. One of the things I like about this Boland monitor is it actually has a stand that allows me to tilt it back just so slightly so that the C6 sits flush on the screen. Let's come back to Calman and click Next. Here, we're going to want to set up our calibration targets. You'll notice on the left side of the screen, we've got a calibration target selector. If I click on the selector, I have options for BT709, D-Cinema, BT2020, User 1, and User 2. These are color spaces already in the Boland display. We can select one of these to make it active, and we can also calibrate that memory. So for the purpose of this video, let's select BT709. Calman's now going to configure the settings for BT709 and give me some options for a color space, a gamma formula, and a white point. I can change these to whatever I want, but keep in mind they're going to be in the memory called BT709 on the monitor. So for the purpose of this demo, let's keep the color space BT709. We'll do the gamma formula at a power 2.4. We know this is an RGB OLED. It should have a near perfect black. And we'll leave our white point at D65. Next, I have an option to choose the delta E formula for the calculation of the correction. I'm going to leave this at delta E ITP. But if you'd like to change which formula you're using, simply click on the selector and choose which one you'd like to use. When completed, press Next. On the application settings page of the workflow, we have some options for pattern insertion and pattern stabilization. The purpose of these is to keep the display stable while doing the calibration process so that nothing gets too warm or too cool, affecting the calibration results. Here, we actually have some recommendations set up if you click on SDR defaults. That's going to enable both the pattern insertion and pattern stabilization and enter the values we recommend from our own testing. If you find that those values are not adequate for your own calibration, you can adjust these as needed. Let's come down and press Next. Now I'm on the pre-cal measurement portion of the workflow. It's important to keep in mind that I have been using this monitor for some development as we've been building our Calman Ready integration, so I'm not quite sure the state that the monitor's in right now, but it's probably not indicative of how it comes out of the box. Let's see how the pre-calibration is doing by coming to the top right and pressing Measure. Okay, the pre-calibration readings have finished, and as we take a look here, we actually do have some room for improvement. Now again, this isn't how the monitor shipped. This is how it was after I was doing some development work with it, so it's in an unknown state at the moment, and we can see that. We can see that's actually tracking about a 2.2 gamma against this target yellow line here on the EOTF chart. We are going a little bit yellow with our grayscale. Our color saturation, or our color checker here, is going a little oversaturated. It looks like it's more in a native gamut mode than it is a corrected mode, and our deltas are showing that we've got a max of about a 7 on the grayscale and 11 on the color checker. So let's come down to the bottom right here and press Next. Now on this part of the workflow, we get to do our display reset. You'll notice we have a bunch of picture modes here. We're in BT709, which is what we chose at the start of the calibration because we want to calibrate the BT709 memory. If for some reason you wanted to measure a different mode and then calibrate a different mode, you certainly could. But let's keep it in BT709 because that's what we want to calibrate, and we're going to press Reset. Calman's now going to reset the picture parameters it has access to, and it's going to load Unity LUTs. After all, if there's already a 1D LUT or a 3D LUT loaded into the display, Calman would be measuring the correction on top of a correction, and we wouldn't want that. So Calman's going to reset the display, and once it's finished, we're going to come back down here to the bottom and press Next. At this point of the workflow, we want to set the luminance value. Here, we're going to want to set the luminance of the monitor for the calibration. I'm going to target about 100 nits, or 100 candelas per meter squared, because I'm targeting BT709 on a broadcast monitor. Of course, Calman has already reset the monitor to a native state. Our native white point is going to be a little bit brighter than our corrected white point. Because of that, we're going to want to target slightly higher than our target in the end of the calibration for the process of calibrating. Calman recommends to set luminance about 15% higher than your target. So if I'm targeting 100 nits, let's target around 115 nits and start from there. Let's come down to Calman and press Measure. Calman is now going to put up a pattern, take a reading, and plot the data. You'll notice we have a peak luminance of about 116.2 candelas per meter squared, or nits. I'm actually at a backlight of about 50. That's pretty close to my 15%, so I'll probably leave it there. But if you wanted to make an adjustment, you can click on these plus or minus arrows and bring it up or down. So as I click it down, you'll notice we come down to 49 and we're at 113.3. So a little lower than 15%. As I come up to 51, you'll notice we're measuring at about 118 candelas per meter squared. So 50 seems to be the right spot for where we want to start. I'll put this back at 50. I'm going to press stop on the reading here in the top right, and let's press next on the bottom right. Now we're at the 1D LUT portion of the calibration process. Calman's going to put up some patterns, take some readings, and create a 1D lookup table to correct the EOTF response along with the white balance. Let's come over to the top right and press AutoCal. With AutoCal pressed, you'll notice the AutoCal setup comes up. We actually have our active grayscale point set to a 21 point grayscale. We'll leave it at 21 points for the purpose of this demo. I'll leave my delta E target at 0.5, but you can adjust this however you'd like, and we'll press OK. Okay, our 1D LUT has completed successfully. It took 18 minutes and 52 seconds with 177 reads. If we take a quick look at the AutoCal here, it looks pretty darn good. We'll see our RGB balance charts are well balanced. We can see low delta E's. Now again, Calman's going through the process while it's doing this, so I expect this to look pretty good if everything went well. But let's press next in the bottom right. And now we'll move on to the next section of the workflow, which is doing the 3D LUT. Just as the 1D LUT did the EOTF and white balance, we're now going to do the color gamut mapping. So I'm going to come up here to the top right. I'm going to press AutoCal. Now this RGB panel from Boland is pretty linear. It's actually a pretty predictable display, so I don't need a lot of LUT points typically to get this to calibrate pretty well. Of course, you can do more LUT points if you'd like to, and you'll still get very, very good results. But let's come back to Calman and let's uncheck Set 3D LUT Grayscale to Unity. I'm going to leave this calibration type on Matrix LUT, but again, if you want to do one of these other points, like a fixed grid 9 point or 11 point, you certainly can. You might find you get a little better results overall. But for the purpose of the demo, we'll leave it in Matrix LUT and let's press OK. I think you'll be pretty impressed with how well the Boland calibrates with that 1D LUT and the Matrix LUT. Okay, our Matrix LUT has completed. It took 47 seconds and a total of 5 reads. Let's press OK, come down to the bottom right, and press Next. Once again, we're at the luminance validation portion of the workflow. Remember earlier in the calibration process, I told you we set the luminance about 15% above our target, knowing that the calibration would bring down the luminance as we got away from our native white point to our calibrated white point. Let's take a measurement now and see how that came out. I'm going to press measure here in the top right, and if you look at our peak luminance here on the left, you'll notice 102.2 candelas per meter squared, very close to that 100 nit target I had. I can come down to that backlight, and I'm going to press minus from 50 down to 49. Let's see how that does for us. Okay, we went from 50 down to 49, and we're now at about 99.7. This is one of those situations where it's really a personal preference. I always like to go just a little bit above my target because I don't really want to reduce anything I don't have to reduce. But of course, 99.7 is pretty much 100 nits. So you could certainly leave this at 49, or you could put it back up to that 50 at 102 nits. Let's press stop, and let's press next. We're now on the post-calibration portion of the workflow. I'm going to come up to the top right and press measure. Calman's going to go through the same grayscale EOTF measurements and color checker measurements that it did at the start of the calibration, so we can see our improvement from the pre-calibration to the post-calibration. Okay, our post-calibration measurements have completed. Let's take a look. If we look up here on our display performance, you'll notice our average grayscale is about a 0.45 or 0.5. Our max is a 0.9, so still under a max 1 on our grayscale. Our color checker average is a 0.36 or about a 0.37 here if we round up, and our max is a 0.87 or 0.89. So we're still under a max delta E of 1 on both our grayscale performance and our color checker, doing that 1D LUT with a matrix LUT. If we look over here on our luminance chart, you'll see our gray line is hitting that target line pretty well all the way up. We're now tracking that 2.4 EOTF. We come down to our delta E 2000 grayscale. Once again, we can see those delta E's have come down quite a bit. And we've also got our color checker here down as well. Our CIE chart here in the top left corner shows our targets are pretty much hitting where they're supposed to hit. So the calibration came out excellent, and these results are exactly where I would expect them to be. Let's come down to the bottom right and press next. Here we have a couple options. So we can go forward and do some additional validation to see how well the calibration actually came out if we do some additional calibration measurements, or we can save a session and view a report if we want to print that out and save that for future use, or we can go back and restart the calibration from the start and do HDR. Why don't we take a quick look at the additional validation, and let's go over to the color checker. I'm going to hit measure in the top right, and we'll see how some of these other colors came out. Okay, our color checker is finished. We have a max error of 1.1 with an average of 0.4. We can see these calibration measurements are hitting their targets. Everything came out pretty much as expected. Let's press next, and let's take one last measurement of the saturation sweeps. I'm going to come up to the top right and press measure. Okay, our color checker is finished. Let's take a look at the results. Our max error is a 0.9 with an average of 0.3. You can see these results here on the delta E are very, very tight. And if we look here on the CIE chart on the right, you'll see once again our measurements are hitting their targets. Once again, that was with a matrix LUT. So you can see this panel is very linear once it's been calibrated with that 1D LUT, and we're able to do this with just a matrix LUT. So let's press next on the bottom right. And let's come over here and hit restart, because I'd like to walk you through calibrating the HDR portion of the Boland monitor as well. But before we do the HDR calibration, let's come over here to the Boland monitor and take a quick look at the menu. I'm going to press menu and press select on the picture setting. You'll notice the backlight's at 50, which is where I left it during the calibration. We've got brightness, contrast, color, tint, all at 0 at their defaults. If we come down here to color temp, you'll see the SDR color space set to BT709, which is what we calibrated. The color temps at user, there's a LUT loaded, and the gains and biases are at their defaults of 255 and 0. As we come down here, there are some other settings, aspect ratio control, picture options, and whatnot like that. If we press menu to exit, we press the down arrow to come over to setup, press enter, and now we can press down to setup save, and we have 3 user memories we can save. I'm going to press select and save the calibration I just did to user 1. So now what this means is I've now saved my settings to user 1. If I want to get back to my BT709 calibration with those settings just as they are, I can set up load user 1, and that will take me right back to where I want to be. So let's come back over to Calman, and now let's start the workflow by choosing HDR instead of SDR. The workflow is going to adapt to the HDR calibration process, and we'll come down here to the bottom right and press next. Once again, we're on our setup page. I don't want to change my hardware setup in terms of my meter because my meter is already ready to go, but I do want to change my pattern source. I now want to calibrate for HDR. So I'm going to come over here to Open Settings panel, press it, come over here to the right, and change HDR from off to HDR 10. We're now in HDR 10, coming out of the G1 pattern source. I'm going to click back off the settings panel, and I'm going to come back down to the bottom right and press next. Here, I'm going to want to choose calibration targets indicative of HDR. So let's come over here to calibration target, click on the select menu, and now you'll notice I have ST2084 for BT2020, I have ST24 for P3D65, and I can calibrate HLG for hybrid log gamma. I'm going to choose ST2084 P3D65 for the purpose of this demo. Calman's now going to configure the display for P3D65 ST2084. I'm going to leave my delta E formula at delta E ITP, and I'm going to come down to the bottom right and press next. Here on the application settings page, we're going to press the HDR defaults so that our pattern insertion and pattern stabilization are now set to the default HDR values that we find work best when calibrating the Boland monitor. Let's press next in the bottom right. And once again, we're at our pre-calibration measurement page. I'm going to come up to the top right and press measure, where Calman's going to go through the same process of putting up a pattern, taking a reading, and plotting the data so we have an idea of how the display was calibrated before we perform the calibration. Okay, our pre-calibration measurement is completed, and I have to say, I probably erased this mode too. I've been doing development on this monitor for quite a while, and I honestly don't remember the state I left it in, but it's clearly not in PQ. It actually looks like this EOTF here is doing gamma, and our grayscale is clearly not tracking D65, and our color gamut is not quite mapping as we would like here. So certainly room for improvement. So let's see how Calman does with that. Let's press next. And once again, we're at our display reset page. I'm going to leave it in ST28A4P3D65 because that's once again what we want to calibrate on the monitor. And I'm going to press the reset button here so Calman can get it in a known state to perform the calibration process. Once that's completed, let's come down to the bottom right here and let's press next. Okay, now we're on the 1D LUT calibration page for the HDR. Let's come back up to the top right, press Auto Cal. We'll keep this in the 21 point PC 0 to 255 range, delta E at 0.5, and press OK. Okay, the 1D LUT has completed. It took 19 minutes and 8 seconds and a total of 223 reads. Once again, if we take a quick look here, we'll see the RGB balance looks to have come out pretty nicely, and our delta E's are low, but again, I do expect that on this page. Let's come down to the bottom right and press next. All right, once again, we're at the 3D LUT calibration portion of the workflow. We're going to come up to the top right, press Auto Cal. I'm going to leave Set 3D Grayscale to Unity off, and I'm going to do a matrix LUT here for HDR. I'm going to press OK. Calman is now going to go through the process of building that matrix LUT to do the gamut mapping. Okay, the 3D LUT calibration is completed. It took 43 seconds and a total of 5 reads. Let's press OK. And then come back down here to the bottom right and press next. Now we're at the HDR transform portion of the workflow. Here, we're going to want to come up to the top right and press Auto Cal. Calman will now take some readings to calculate the HDR transform. Okay, the HDR transform has been calculated, and we're going to come down to the bottom right and press next. We've now made it to the post-calibration capture portion of the workflow. Let's come up to the top right here and press measure, and let's see how that EOTF, white point, and color gamut map came out. Okay, our post-calibration measurements have completed and have come out just about as we expected. We've got our RGB balance here tracking pretty well across the scale. We've got our EOTF here tracking really nicely all the way up to that hard clip, which is what you would want with the broadcast monitor used for mastering content. You wouldn't want to be grading against your roll-off. And then you've got a max color checker of about 1.4 with an average of about 0.5. You've got a grayscale with a max error of about 0.8 with an average error of about 0.5 again. So our grayscale here on our bottom delta E chart is tracking really nicely. And of course, our delta E on our CIE here is tracking really nicely. And if we do look at our measurements here on the CIE diagram, we're pretty much hitting those targets. So our HDR has come out very well, as we expect. But let's come back over to our Boland here and let's press menu, because I'm going to want to save this. So I'm going to press menu, hit select on the picture mode, and you'll notice we've got our backlight at 100. We've got our color temp grayed out here because we're in those HDR modes. So we're going to come down here to picture option. You'll see we're in HDR ST24D65. So let's come back out of that menu, come over here to setup, press enter. We'll say setup save, press enter. We're going to save that to user 2, and we're going to say yes. So now we've stored these calibration settings in user 2. If we want, we can come back to the menu, come over to setup, hit setup load user 1, and now the Boland monitor has loaded the BT709 calibration we did for SDR. If we want to load user 2 for HDR, we do the same process. Let's go check that really quick. We'll hit menu, enter on picture. Once again, our backlight's at 50, brightness, contrast, color, tint. We're back in SDR color space BT709, and we're out of that HDR mode. Okay, we've now calibrated the Calman Ready Boland monitor using Calman Studio, the C6 HDR 5000 colorimeter, and the G1 pattern source. If you'd like to calibrate the other color spaces or HDR modes, you can repeat the workflow steps as described in the video. We hope you enjoyed this. We'll see you on the next one.